Okay, so welcome to the third in the series on mechanical rigidity for 3D printing frames. Here's one I prepared earlier. This is a representative of a Fisher 3D printer using straws, paper and tape, which I absolutely love, as I've mentioned in the other frames, because it's so quick to do. Also, you can easily show, for example, where a strut may not necessarily be sufficiently strong for its span, and also when it comes to use of panels, if I flex this, you can see clearly. Can you see that bowing there? That's really useful to show, because if you have, even if you had a 3mm piece of panel, you might not necessarily see that kind of flexing, and you wouldn't know where the stresses and strains on the piece would on the panel that you're creating would necessarily be. But this clearly just demonstrates it very, very easily and very clearly. So and some of the other ones who actually have so much sufficient stress is actually tore across the paper, which is just the kind of thing that you need to know before going to a full design. Now, when we, in the previous video, one thing we highlighted is we created this the Fisher layout, but then I noticed that the original Fisher doesn't have any kind of support here. So not only can the rods bend in, I mean they're actually the Z rods, but there's no join anywhere between here and here on the Fisher, and it's really quite long. So I was concerned about twisting and bowing, shearing and bowing. So I'm going to hold the base down, and I'm going to show you what happens when you push the top and look at it. And there's nothing to stop that. Really to stop that from happening, especially there's no sort of twisting a thing, and you can see this piece is shearing sideways on a thing. So I thought of an idea to fix that, and it's very simple. Hey, first video showing a piece of cardboard, yay! I'm deliberately using cardboard because it is much more sturdy than paper. And obviously I've got to work out which way round it goes on. Not that way. Which way did I just turn it? Oh wait, yes, brilliant, okay. Alright, so just placing this panel on here alone, and we should now be able to highlight just how much the panels flex about even with this. So what we are going to do is attach the panel in the three places that I advised on the forum. Sorry about the noise from the tape. It sort of overloads the camera, so I won't speak when I'm actually taping. 1, 2. Now it will need 9 attachment points. 3. Let's just do 3 for now. And already, obviously, when you have a solid panel, the shearing that you can see in there won't occur. In that flexing in that piece of paper, there won't occur. I think it's fairly. Now look at that thing on the compared to that side. Dunk, 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 dunk. Yet on this one, yeah. You see why I suggest having this extra panel. And let's do again. Yeah. Put it on the paper first, then the cardboard. Well, duh. Yeah. See how quick this is compared to getting a brilliant spanner out and wasting your time and your money doing things using expensive materials and your time. and you just using this paper, cardboard, your teeth and tape, you know, and a pair of scissors, you can very, very quickly come up with, you know, overlap the microphone, come up with you know, a quick demonstration of a concept for improving a 3D printer. There we go. All right, ready, let's try it now. Let's hold the base down. It's better, but it's better. I suspect that what we're seeing is just because this is paper. I figure if you used cardboard for these panels, it would be much a better demonstration of the thing. But the main thing is that this using attachment here will make sure that the panel doesn't. You can see it. It's trying to parallelogram even just paper. Look at that. And that wouldn't happen with cardboard, MDF or Lexan or whatever. So you wouldn't see that effect. But the bowing of the Lexan would occur in the entire thing because it's really very long on the fissure. So that entire panel will bow out. And then any warping that occurs here or here or here will be significant, and would think, I'm very interested to hear from people who've actually got a fissure, what they find when they do this thing of, you know, putting your hand over the thing on the base and then just wobbling the whole thing side to side. So yeah, thank you very much. I love 3D printing and doing mechanical design, especially when little bits of paper and stuff. Thank you very much.